question number 1, we have a calculator if we need it. We've got a lovely table of function values, and they want us to approximate the integral using a midpoint Riemann sum with 3 intervals. So I know some of you do not like to do this, but it's going to save you some headaches. We're going from 0 to 6, and we are dividing that into 3 equal intervals of width 2. So 0, 2, 4, and 6. So I have 1, 2, 3 rectangles that I'm going to add up. The base of each rectangle is 2. The height of each rectangle comes from the midpoint. So the midpoint of my first rectangle is 1, and the height there is 25. My second rectangle, the midpoint is x equals 3. The height there is 68. And then we have our 5, and our height is 95. So I'm just going to grab my calculator, pull out the 2, and so I have 25 plus 68 plus 95 for a grand total of 376. All right. Question 2, we also have a calculator. It says f is increasing. Which of the following could be the value of the integral? All right. So again, they're asking us to estimate the area under the curve. We're going from 0 to 3. I have values anywhere from 0 to 54. Clearly not to scale. We're going up by 0.5s in terms of data, but they are telling me that this graph is increasing. And if this graph is increasing, if I use left endpoints, it's going to be an underestimate. If I use right endpoints, it's going to be an overestimate. I'm just going to start to kind of process of elimination. I'm just going to start kind of rule some things out. So if I just go straight there, it'd be a triangle, and I'd have 1/2 of the base times the height. And so I'm just thinking, all right, so 27 times 3 gives me 81. Now, I get it, like we definitely are estimating, but I'm feeling like I can at least rule out a couple of answers, right? You know, we could go ahead and do all 6. Since we have all those data points, and let's use a left sum. So each rectangle has a width of 0.5, and let's go do all of the left heights. So I'm kind of thinking this is going to be an underestimate. So the base of my rectangles are all 1/2. They didn't tell us how to estimate, so I'm just kind of saying let's just try some things. And my heights are 0, 4, 10, 18, 28, and 40. So that's my left sum, and that is an underestimate. So that means it can't be A. Okay, so let's do a right endpoint. So again, 0.5. If I use my right heights, I have 4 plus 10 plus 18 plus 28 plus 40 plus 54. And I get 77. That's a right endpoint, and that would be too much. That's an overestimate. And so that's why we're going to pick option B. So again, the idea that f is increasing allowed us to know, right? Think about if your graph is increasing, a left endpoint will be too little, and a right endpoint will be too big. So I went ahead and did the right and the left. Kind of get to know that I was going to be in the middle. Okay. All right, let's take a look at 3. They want to know which of the following is equivalent to the integral. So remember, an integral is saying find the area under the curve, y equals radical x, from 2 to 6. And if we're finding the exact value, we are using an infinite number of rectangles. So we said, well, that means n is going to infinity, right? We said we're still adding up base times height. The base is our delta x. And how do we find delta x? It's b minus a all over n. So my base is 4 over n. All right, that's a big deal. So I can probably rule out b and d. Then we need to find the height, and the height comes from the function, and so this has something to do with the square root. So it's the square root of the set of x values. Well, think about our x-axis. Our x-axis is going from 2 to 6, but we're dividing it into billions of rectangles. But this little distance is delta x. So we're starting at 2, and then my next x value is 2 plus delta x. Then 2 plus 2 delta x's. So of the 2 that are left, I want the square root of 2 plus something times delta x. All right. So let's take a look at 4. It's like similar, it's going backwards, right? Now, there is no limit in front. That's okay. It just means that we don't know the number of rectangles. And that's okay. They're just saying, oh, we're going to use n subintervals. But the same kind of idea. I'm adding up a bunch of rectangles, and I have the natural log of something times this delta x of 5 over n. And if delta x equals 5 over n, that means the length of the interval is 5. Oh, okay, well, that doesn't help. 2 to 7, 0 to 5. So that doesn't help. Okay, but that's fine. If we could have eliminated answers, that would have been great. All right. So the big question is, what's going to go in here? Are we going from 2 to 7? Well, let's check. I'm just, kind of working backwards. If we're going from 2 to 7, then the inside should say 2 plus delta x times k, which I think it does. Yeah, if we're going from 2 to 7, the 2 should be in here. I'm sorry, the 2 should be in here, not in here. And I'm just checking this. We don't want a 5x, right? The 5 is the length of the interval. So I'm thinking, should be letter A. Working backwards. I put C as our answer, didn't I? Natural log of x from 2 to 7. I'm just timing out, sorry. Either I have a wrong answer, maybe I changed this, doesn't matter. Yeah, we don't want a 5 in there for sure. The 5 is the length of the, yeah. Okay, I think I have a wrong answer there, so I will send a Schoology message on that and we'll fix that. Okay, woo, sorry. All right, let's take a look at number 5. It's kind of like what we were just doing on 3 and 4. But it's saying, what is the value? Right? So when we talk about a limit to infinity, we're saying find the exact area. And what's the function? Well, let's see. The delta x is 3 over n, which means the length of the interval is 3. And in here, I have my delta x times k. That means my a value is 0. So we're going from 0 to 3. And the function is something squared, right? So I don't see something plus inside my function. So that means my x-axis is starting at 0. But this is telling me then to stop at 3. So kind of working our way backwards like on 4, I think we're just going to take an antiderivative and go plug in our bounds. And that's where we get our 9 from. All right, let's take a look at question 6. Oh, let's see. They are telling us that a left Riemann sum, a right Riemann sum, and a trapezoidal sum are all used to approximate the value of this integral. Which of the sums gives an underestimate? Kind of already had this conversation. right? Because this graph is going up, a left Riemann sum will give an underestimate. A right Riemann sum will give an overestimate. That conversation we already had. A trapezoidal sum, because the graph is concave down, a trapezoidal sum also gives an underestimate. And that's where we get the answer of D.